Hey everyone, in this video, I'll be talking about indexing. We'll see how indexing works under the hood to optimize your queries and make them run faster. Indexing is a technique which is very widely used in relational databases as well as non-relational databases. We'll be talking about indexing in the context of relational databases, but the same mental models are applicable for non-relational databases. In a relational database, you'll probably be dealing with a table such as shown over here. Suppose this table is called students table, and over here you have 5 columns: ID, name, age, class, and section. This is the rough data structure of a row of the table. I have assigned the memory requirement for each of these columns. An ID field would be of int type, so 2 bytes. The name would be a varchars, which is 62 bytes. Age again would be integer 2 bytes. Class integer 2 bytes again. Section would be varchar1 3 bytes. So overall 71 bytes for every row. We need to take a look at how our database stores the information inside our hard disk. We would be able to get a better understanding of what kind of operations takes place when you're running queries and see which of those operations are costly and how we can optimize those. The database is not stored in memory as a single long chunk of memory. It is partitioned into smaller sections called pages. A page would be a block of memory which is stored inside the hard disk, which is roughly of fixed length. So here, page 1 would be 150 bytes, page 2 would be 150 bytes, and so on. Suppose you have roughly like 100 rows inside this table. So as we saw, every row will be of 71 bytes. So a page of 150 bytes would cover roughly 2 rows. Page 1 has row 1 and row 2. Page 2 has row 3 and row 4 up to page 50, which has row 99 and row 100. This data structure on how the database is modeled inside the hard disk is called a heap. The heap is your internal representation of the database, which contains pointers to each of the pages. Let me introduce a term which I would be speaking about throughout this video, which means a very specific thing, which is disk IO. Whenever your application reads something from the hard disk, it's called a disk IO, which is a read operation. Whenever a read operation happens, it doesn't read a specific row at a time, it reads a page at a time. This is just the way a database system is modeled. Whenever you are searching for row 2, your database system will get this whole page. It will get row 1 for free. Similarly, for all of the other cases. Disk IOs are one of the most expensive operations when you're running a database query. And in order to optimize them, you essentially want to optimize the number of disk IOs that happen. Okay, let's look at this with an example. Suppose you have a query. Select star from students where class is equal to 5. So as you saw in the relational model, you have like 100 line items here. That is 100 rows over here. And every page has 2 rows. Now this query, which is there, we have to iterate through every row and see which row satisfy this condition. Whenever it satisfies the condition, we'll put it into a buffer. And at the end, we'll return the contents of the buffer. That is how this query would get executed. So basically, your database cursor would basically start over here. It will load page 1. It will check this condition. Is class 5? Yes. It will put it in the buffer. It will check this one. Is it class 5? No, it won't put it into the buffer. Then page 2 will get loaded. This particular row will get loaded. This particular row will go to, and so on, up to page 50. Now, as you saw, for this particular query, we had to iterate over all 50 pages. And if every page took about 1 second, you can assume this whole query would take about 50 seconds to execute. Now, let's see a different way on how we can approach this. An index is a table where one of the properties which is there inside your original table is used at least to create the new table. And it always has a reference back to the original table which was there. So you have, now we are indexing by the property class, which is over here. Now, based off class, let's basically for class 5, you have ID 1. For class 5, you have ID 3. For class 5, you have ID 99, and so on. You map it out inside this particular small table. Now the overall height of every row item over here is just 4 bytes because you have just class and you have ID, both of which are ints. Now, if you look at it, let's look at how this particular index will be stored inside the hard disk. Now, as we saw, our page size is 150 bytes. So if a particular row is just 4 bytes, then 150 by 4 is rounds out to 38. So every page will now have 38 rows. Okay. So what we'll do is whenever we are running this query, we know that class is equal to 5 is basically what we are looking for. So it is indexed. So we'll first come to the index. So we load page 1. We got all of these items now in memory. We saw which of these rows have class equal to 5. Then we go to page 2, then we go to page 3. And in just 3 pages, we got loaded up all of the specific students which are in class 5. So you just did 3 disk-IO operations over here. Now that you have the IDs, now you can use those IDs, those references to directly access the specific pages over here from the hard disk. This will reduce your disk-IO operations to a minimum. This way, we did 3 disk-IO operations over here to retrieve the 5 students who were there in class 5. Over here, this meant page 1, page 2, and page 50. Suppose the rest of the pages did not have any students in class 5. Now, in this would mean we only did 6 disk-IO operations to retrieve the data, which would mean the time which was taken 6 into 1 second, which is 6 seconds. So you optimized a query which would normally take in 50 seconds into a 6-second query. This is all about how the database indexing works. Thank you.